Okay, now we will discuss exercise 1, page 258, questions number 1. A sign of mass 1700 kg hangs from the end of the vertical steel glider, meaning that your object here is hang with the steel glider, meaning that there's a tension, and at the same time the object is experience their weight mg. Okay, so here they give you the information. Mass is 1700 and the cross-sectional area A is 0.012. So the first question they ask you, what is the stress within the glider? So the stress equation is F over A. Okay, so F here we are referring to the tension. Okay, at the same time your tension also equals to mg. Okay, so you substitute mg and then area is the cross-sectional area A. Okay, so mg just now is 1700, g is 9.1, and the cross-sectional area is 0.012. Okay, so try to press calculator, and the answer that you get is 1.39 times 10 to the power of 6. And the unit, because it's force, so it's Newton. Area, so it's Newton per meter squared. Okay, so this is questions 1A. Okay, next we go to questions 1B, where we want to find the strain of the glider. So the strain here, we can try to use this equation where your strain is equals to elongation over original length. But the problem is we don't have the elongation, we don't have the original length. So we cannot use this equation to find the strain. Okay, so we must use the other equations where the Young modulus equals to the stress over strain. Okay, so the strain here is the stress over Young modulus, where your stress just now we get is 1.39 times 10 to the power of 6, and the Young modulus is 20 times 10 to the power of 6. Okay, so the answer for strain is 6.95 times 10 to the power of negative 6. And there's no unit for strain because the elongation in meter, the origin length also in meter, so they will cancel each other. So there's no unit for strain. And lastly, they ask you to find if the glider is 9.5 meter long. So the original length is 9.5. They ask you to find the length, meaning that they ask you to find the elongation. Okay, so the strain just now we get is 6.95 times 10 to the power of negative 6. And the elongations is the value that we want to find. Original length is 9.5 meter. So we don't need to convert because it's in meter. Okay, so after press the calculator, you will get 6.6 times 10 to the power of negative 5 Newton per meter squared. Is it this is the correct unit? Actually, it's wrong based on the answer given. Okay, so the answer, the unit actually is in meter because it's elongation. Okay, so it's elongation, meaning that we want to find the length. Okay, so this is the wrong unit. So what is the unit for elongation? What's the unit for elongation? Yes, the unit is meter. Okay, the unit is meter because we want to find the extension. Okay, so the unit is meter. Please change this, cancel off the unit is in meter. Okay, so the value, the unit they give actually is wrong. Okay, so change to meter. Okay, so this is question number 1. Okay, next question number 2. 15 cm long. Okay, so they give you the original length 15 cm. We change to 0.15. Stressed by, so the allocation is 3.7 millimeter. Change to meter. By the force of 13.4. So your force is 13.4 Newton. The tender was approximately round with the average diameter. Okay, so they give you the diameter 8.5 millimeter. Later you need to convert it become meter. So calculate the Young modulus. Okay, so this one is easier because Young modulus equals to stress over strain, where our equation is F over A, and then elongation over original length. Okay, so after we rearrange back the equation, you will get F over A and then original length over elongation. Okay, so you substitute with the value. The F is 13.4. The elongation is 0.15. Okay, aerial. We don't have area, but we have a diameter, where your aerial is equal to pi r square or pi d square over 4. Okay, so you substitute inside the value. Okay, you will get the answer for the area. You try to substitute 5.67 times 10 to the power of -5. And remember, change the millimeter to meter first. Change times 10 to the power of -3 first. Okay, then only you calculate. And the value that you get for the area is 5.67 times 10 to the power of -5. Okay, and then the elongation 3.7 millimeter. Also, we need to convert it become meter. And the final answer that you get, okay, you can try to press calculator. So you will get 9.573 times 10 to the power of 6 Pascal. Okay, actually Pascal you also can write it as Newton per meter square. Okay, either one. Okay, either one. So this is questions number 2. Okay, you may pause the video if let's say you want to do the calculation. Okay, next question is number 3. Question number 3. An object of mass, so they give you the M, suspended from the steel cable of the length, original length, and cross-sectional area A. Determine the extension, meaning that we want to find the elongation when the mass cable system at rest. So the first one, your system is at rest. Okay, so first one, you must draw first the free body diagram where your object is suspended with the cable, meaning that we have tension and we also have mg weight that always acting downward. So for the first questions, if your system is at rest, meaning that your A is equal to 0. Okay, so when A equals to 0, F net equals to MA. A equals to 0, meaning that your F net also will equals to 0. Okay, so meaning that your tension minus mg equals to 0, or the tension equals to mg. Okay, so if let's say you want to find the elongation, meaning that we must use the equation where our Young modulus, just now from question number 2, we know that it's equals to F over A, then your original length over elongation. So in order to find the elongation, you must rearrange back. Let elongation become subject. So we must use F times original length over aerial times Young modulus to find the elongation for each questions. Okay, so now for questions number 1, 3A, meaning that our elongation will be equals to mg. Your F will convert to mg. L0 just now is 40 meter. And then your area is 1 times 10 to the power of negative 4. And the Young modulus is 2 times 10 to the power of 11. Okay, so you substitute all the value inside and then press the calculator and you will get 5.89 times 10 to the power of negative 2 meter. Okay, so this is for questions number 3A. Okay, so I change color. Okay, now 3B. When the system moves upward with constant speed. So again, V constant meaning that your A is also equals to 0. Okay, so when A equals to 0, similar, your elongation, you will get the same answer where is equals to 5.89 times 10 to the power of negative 2 meter. Okay, so both answer same for 3A and also 3B. Okay, because V constant A0, your F net also equals to 0. So therefore, at that time, our tension will equals to mg. Okay, we go to question 3C. Your object or the system is moved upward at constant acceleration. Okay, at constant acceleration. Okay, so meaning that now your F net equals to MA and your A is not equals to 0. A is equals to 3. So you must substitute inside 3 meter per second square. Okay, so your equation will become, because it's moving upward. Okay, so your tension, this is your mg. Okay, and your system is moving upward. So meaning that we must take tension minus mg equals to ma. Okay, so your tension here no longer equals to mg. The tension here will equals to ma plus mg. Okay, so calculate what is the tension. So tension that you will get is equals to 38.430 Newton. Okay, then you substitute into the equation where elongation equals to tension. So now your tension no longer equals to mg because our acceleration is not equals to mg anymore. Okay, so it's our acceleration is equals to 3. Okay, not 0. So you substitute inside 38.430 and the original length is 40. Okay, and then the area is 1 times 10 to the power of negative 4. And lastly, the Young modulus is 2 times 10 to the power of 11. So the answer that you get is 7.69 times 10 to the power of negative 2 meter. Okay, so this is the solution for question number 3. So next question number 4. A wire has a mass of 10 grams and the length is, original length is 2.5. So this is a mass. And the force F is 100 Newton is applied to the wire and extend it by, so this is the elongation, 2.3 millimeter. determine the Young modulus of the metal of the wire. Okay, so Young modulus from the equation just now that we derived, F over A L naught over E. When if let's say we rearrange back the equation, so your F is 100, original length is 2.5, area is not given, but the allocation is given 2.3 times 10 to the power of negative 3. Okay, so now area, we don't have area. How can we find the area? Okay, they give you the density. Okay, so density equals to mass per volume. Okay, so the mass is 10 grams. So 10 times 10 to the power of negative 3. Change to kg. Okay, volume. Okay, volume, if let's say this is a wire, volume meaning that you must use the area times the original length. Okay, so the area we don't have, and the allocation, the original length is 2.5. Okay, is equals to the density 2.7 times 10 to the power of 3. Okay, so you will get the area equals to 1.78 times 10 to the power of negative 6. Okay, so you substitute the area that you find just now, substitute into the equation. Okay, you substitute inside and then you will get the answer. Okay, so the answer that you get is 7.34 times 10 to the power of 10 Pascal. Okay, so this is the Young modulus. Okay, next question is question number 4. The strength energy stored in the stretch wire. So strength energy equation is equals to U equals to 1 over F E. Okay, where our substitute inside, F just now is 100 and the allocation is 2.3 millimeter. Okay, so millimeter, we change it to meter. Okay, so you will get the answer for the strength energy is 0.115 joule. Okay, 115 joule. 115 joule. Okay. So if finish, we will go to questions number 5. Okay, questions number 5. An object P with the mass 0.5. So 0.5 is our M. Hang on a vertical tungsten wire, so the diameter is 0.22 millimeter. And the original length is 1 meter, hanging from the bottom of P, where your P is a copper wire with the diameter of 0.5 millimeter and the length is 1.5, that support an object Q with the mass 0.35 kg. Okay, so if you draw meaning that this is your P and this is Q. So meaning that we have two objects and it hangs with two different types of wire. The first one is the tungsten and the second one is the copper wire. Okay, so this is your T1. Okay, and this is your T2. Okay, at the same time, your Q also experience a tension, and both are the same because both are same wire. Okay, it's just that the direction is different. If you're referring to P, your tension is come up from the object P, meaning that it's going downward. But if you're referring to the object Q, meaning that your tension must come out from object Q, your tension is acting upward. Okay? Okay, so if you draw free body diagram, for P, okay, let's say this is P, meaning that your P will experience T1, which is a tungsten wire, and it will experience T2, meaning this is a copper wire, and at the same time, there is a Mg, okay, Mg from object P. Okay, so this is a free body diagram for P. Okay, for Q, free body diagram for Q, there's a copper wire, so it is T2 and also Mg from object Q. Okay, so this is a free body diagram for P and also for Q. Okay, so now we want to sketch the free body diagram. Okay, so this is the free body diagram. Okay, 5B is determine the tension in both wire. Okay, meaning that we want to find what is the tension T1 and also T2. Okay, so based on the equation from P, okay, based on the equation for P, because it's a equilibrium or it's a static, so meaning that your T1 minus T2, or we can say T1 equals to T2 plus mg, where your m is mp lah, okay, mg. Okay, so now our T1 we don't know, T2 also we don't know. This is the value that we want to find. But mg for P is 0.5 and the value for G is 9.81. Okay, so this is the equation, first equation. And here we have two unknown. The first unknown is T1 and the second unknown is T2. Okay, so here we have two unknown, T1 and also T2. We have two unknown. So when we have two unknown, we need to have two equation. So we need to form another equation from object Q, where object Q, your T2 will equal to M mass for Q times G. Okay, so your T2 will equals to M for Q, just now is 0.35. Sorry, not 5, it's 35. And G is 9.81. Okay, so you will get T2 equals to 3.43. 3.43 Newton. Okay, so we already found the first tension. Okay, so you substitute inside the first equation and you will get T1. So the answer that you get for T1 will equals to 8.34 Newton. Okay, next, find the total strength energy of the system. Okay, so if you want to find the total, you must find one by one. Okay, you must find one by one. Okay, where our equation is equals to, our equations for the energy is equals to, I change color, wait. Okay, the equation for the energy is equals to U equals to half F times elongation. Okay, so we have two wire, meaning that we need to find two tension. Okay, we need to find. Okay, so the first one, U for, let's say the first one is the wire for tungsten. I write T. So U for tungsten, you must use U for tungsten is T1. So just now the T1 value is 8.34. Okay, sorry, 8.34. Okay, so you can calculate 8.34. Okay, but we don't have the allocation. Okay, so after you write U equals to half FE, F is 8.34, but you need to find the allocation. So the allocation, we can use Y equals to F over area L naught over allocation. Okay, so the allocation for the tungsten, okay, you substitute all the value, you will get the allocation is 6.09 times 10 to the power of negative 4. Okay, negative 4. Okay, so you substitute inside here the allocation. Okay, you will get the energy is 2.54 times 10 to the power of negative 3 joule. Okay, negative 3 joule. Okay, and you use a similar method, to find the energy for copper wire. Okay, so you substitute half F that we get is just now the value is 3.43. Okay, and the allocation similar, we must use the equation just now, and the allocations that we get, allocation for the copper is equals to 2.18 times 10 to the power of negative 4 meter. Okay, so you substitute inside. Okay, you will get 3.74 times 10 to the power of negative 4 joule. Okay, so these are the strength energy for both wire. But the question asks to find total. So your U total is energy for the tungsten plus energy for the copper. Okay, so you add on, you will get 2.91 times 10 to the power of negative 3 joule. Okay, so that's all for this subtopic. Thank you.